Hello, we continue lecturing on the probability theory, and these lectures are not about some abstract knowledge. The conception is to give you the theory in close connection to some practical applications, right? The previous presentation was about roulette, and we concluded that there is no playing system that allows you to win regularly at roulette. The probability theory only helps you to control risks. Maybe some were disappointed with that conclusion. Today it's quite different. We consider the Lotto game, and I'm going to convince you that there is a way to win regularly, at least hypothetically. So, if you wish some income, but tired to wake up early every day and go to work, stay with us till the end of the lecture. Consider a classical Lotto. One should guess, for instance, 6 numbers from 49, and there are usually something like 10 million participants, each buying a card on €2, for example, so the total fund is 20 millions, but the only half of that is used for winning premium. It's quite profitable business, by the way, so that's why it's usually monopolized by state. It could be different rules, but classically the winning premium is divided equally on 4 categories for those who guess 3, 4, 5 or 6 numbers. Recently there are a lot of modifications in rules, but we will consider the classical variant. We can calculate the chance to guess a certain amount of numbers. I will omit that. It's a good exercise when you want to practice yourself in combinatorics. Here I only write down the final result, the middle column. And having these numbers, we can easily calculate how many from 10 million participants would guess in average a certain combination. And correspondingly, we can calculate the winning premium for each category, the last column. That was a review of the rules. Now let's see whether the probability theory could help us to build a winning strategy. In the previous lecture, we introduced random variables that are very different from familiar algebraic variables. You know, algebraic variables point to fixed numbers, and also the functional relations are fixed. For instance, if y is x squared and x is 2, y can be nothing but 4. Well known. Random variables are different. They appear in certain range, and each value in this range is assigned to a certain probability. It could be a discrete range or continuous range. The only condition is that the sum over all possibilities or the integral over all available range should be 1, because something should definitely happen with probability 1. Also, functional relations are modified. For instance, if the random variable x is equally distributed in the range from 0 to 2, then the random variable y, which is square of x, is distributed in the range from 0 to 4, unequally distributed like shown in this figure. When we participate in several Lotto rounds, our win or loss is a random variable, and we are going to calculate its probability distribution. We play, for instance, twice a week, 100 times a year, and we know the chance, the probability to guess 3 numbers in each particular round. But what would be the year balance? From the previous lecture, you know that this is defined by the binomial distribution, which gives you the probability of n small successes from n large trials. Okay, I use the online binomial calculator. The chance is 1 from 57, 100 trials, And here is the probability distribution. Most probably it would be 1 or 2 successes from 100 trials. But we need the result in terms of money, so we multiply the number of successes on the premium. We get, in case we guess 3 numbers, and here is our year win distribution. The average win is 25 euro, which is not much. But there is also possibility to guess 4 numbers. We can calculate again binomial distribution and discover that it is hard to guess even once a year. Hard, but possible. If we recall that in terms of money, we find that it gives another average win 25 euro per year. Now we have a mathematical issue. There are several winning possibilities how to calculate the net winning distribution. To address this question, we have to learn how to sum random variables. For instance, we have variable x distributed like this and variable y distributed like that. How their arithmetic sum will be distributed? We can write down the table with all possible combinations, the so-called frequentalist approach, and we will end up with the following distribution for the sum. Please note that the sum of random variables is defined on the much larger numerical domain than both x or y, for the evident reasons. Another important notice: that all is valid only with the assumption that x and y are independent variables. It means that they do not influence on each other. But writing the combination tables is possible in the only simplest cases. For general situation, we need better mathematical tools. You can learn that the distribution of the sum is calculated as a convolution of the particular distributions. It looks like each peak in one distribution is mirrored up with another distribution. Well, I'm not sure that we always need to calculate the complete distribution. In many cases, what we need to know is the average of the random variable. You can see that in this case, both x and y have the average 1, and their sum has the average 2. Again, there is an easier way to calculate it. It was derived in the probability theory that the average of x plus y is nothing but average of x plus average of y, exactly same as in the case of algebraic variables. Now we are able to calculate the net win from 2 combinations. The probability distribution would show 2 peaks, bigger and smaller, and the average win would be 50 euro per year. Exactly same way we will account for all 4 possible combinations. The probability distribution appears quite complicated, but the average yearly win will be 100 euro. That was an expected win, but don't forget that we paid 200 euro just to buy the cards. To account for that, we have to shift the origin of our money coordinates, and at the end, our yearly balance would be minus 100 euro. Good. Minus 100 euro when invested 200. 50% loss. You remember at roulette, it was just few percents lost. How about my statement that you can win in Lotto regularly? Wait a moment. There is an important difference between roulette and Lotto. At roulette, you play in fact with a playhouse, even if there are many players at the roulette table. In Lotto, in contrast, you play with another gamblers. Look again at this table. There is a fixed chance to guess a certain amount of numbers, and we cannot affect that. Anyone who tells you that you can affect this chance is incorrect. It's fixed. But what we can affect is the number of winners in each category. Correspondingly, we can affect the amount of winning premium in each category. In contrast to roulette, it's not fixed. I'll show you the statistics. That is the result of some particular Lotto 2-year track. Blue pillars is the number of players guessing 5 numbers, and the red curve is the calculated distribution assuming that all players choose numbers randomly. So you see that the blue distribution is much wider than the red curve. What does it mean? That means that there are certain actually happened combinations that a lot of people can guess. And there are certain combinations only few could guess. That means that people fill their numbers not randomly, but there is strong psychological pattern in it. What is this psychological pattern? I found that people choose their numbers like a team to some risky expedition. They consider the personal relations between members. For instance, for some reasons, they think that 2 consecutive numbers will win less likely than any other numbers. Correspondingly, the probability that couple of consecutive numbers will be chosen is less than any other numbers. For instance, 20% less, like in this illustration. What is the probability that 2 consecutive couples will be hired into your expedition team? To answer this question, we have to learn multiplication of random variables. For the case of binary variables, variables that can take only 2 values, 0 or 1, or false or true, the multiplication means the probability that both x and y happen simultaneously. They both are true. The very important property of multiplication is that the average of multiplication is just the multiplication of 2 averages. That is not very evident property, by the way, but it was proved in the probability theory. Using this property, we can evaluate that choosing 2 improbable couples is just 36% less probable than choosing any other couples in this case. And how about 3 consecutive numbers? Your psychological ego would instinctively notice 3 conflict relations among them. So the probability of choosing this triple would be almost 50% smaller than choosing any other 3 numbers. We can generalize these speculations and find that 5 consecutive numbers will be chosen somehow 10 times less than 5 non-consecutive numbers. But that's all about human psychology. Will these consecutive numbers indeed less often selected in the Lotto device? No. The numbers are just labels on the balls. We can label them differently, for example with colors or with pictograms, and saying that 2 balls with consecutive numbers are less probable than the other is the same as saying that green and yellow balls are less probable just because these colors are neighbors in the rainbow. So, the chance that 5 consecutive numbers would happen is exactly the same that for any other combination of 5 non-consecutive numbers. The chance is very small but fixed. But if it happens, much less gamblers would guess it. In the considered example, that means that 10 times gamblers would guess 5 numbers. And that means that the premium would be 10 times larger. This effect affects also 4 and 3 numbers guessers, but not as dramatically. But we still don't know what is this pi value, even approximately. This is psychological bias. We cannot calculate that from the probability theory. It's more about psychological sciences. It also should depend on the people mentality, country, and so on. We can find that experimentally. In the Lotto I have analyzed, indeed there is a correlation. More consecutive couples happen, less players are able to guess that. Yeah, I analyzed only till 2 consecutive couples, but I believe the tendency is clear. I plotted the prediction for the different pi values, and it seems that pi is about 0.85. It means that people choose consecutive couples somehow 15% less than the other couples. So, now our playing system is clear. Bet always on consecutive numbers. Better 6 consecutive than 5. There are 44 such combinations in our Lotto. Just fill every time 44 cards and do it 100 times a year. Fill every time the same way, all 6 consecutive numbers. With such a playing budget, 44 cards 100 times a year, if you choose numbers randomly, the probability theory predicts that you will lose 4,400 euro in average per year. But we would not choose numbers randomly. We are going to explore the psychological bias. Our model shows that at a certain pi value, we move from the negative domain, loss, to the positive domain, win. I stress again that all depends on the rules of the specific Lotto, and of course pi value is different in each country. But with our assumptions, it seems that we are able to come to the average income about 2,500 euro per year. And that is because the average winning premium will be larger. Also, the probability to win them will be unchanged. So, I fulfilled my promise. Yes and no. Unfortunately, there are certain problems in my system. It relies mostly on the guess 5 numbers events, and that happens, not very often. Which consequences it implies? Every year, when we don't guess 5 numbers, we will lose in average 4,000 euro. But when we guess 5 numbers the first time, we will compensate all the previous losses. According to the probability theory, that would happen something like once in 12 years. That means that our enterprise should run for at least 12 years or longer. To reach the theoretical average yearly income of 2,500 euro, we need also to include guess 6 numbers events, and that happens something like once in 3,000 years. I'm not sure that it's a very realistic business plan to run for 3,000 years. But that was just an idea based on the specific Lotto and on the statistics in the specific country. You should not follow my formulas. I think you also should put some efforts on the way to your prosperity. There are 4 points. First of all, identify the Lotto with the high dependence of winning premium on the psychologically biased numbers choice. Then, analyze which combinations are most and least chosen. It could be not necessarily only consecutive numbers. There are probably hundreds of psychological patterns. You can do that with the technologies of the big data analysis, or you can subscribe for the course of psychology in the college. Don't start business before making a comprehensive mathematical model predicting your average yearly win and, what is quite important, the statistical deviations from that. And finally, start making money with betting on the least chosen combinations. Good luck, but honestly, if you are able to perform all of that, I guess you can have much higher and more stable income as a financial analyst in some company. With this comment, let me finish today's lecture. Bye.